Okay. You might be wondering what latitude and longitude has to do with the normal distribution, and nothing would be the answer to that. Hi Ben. Now the only reason we're doing this, and you'll also notice it's 11:01, and chapter 11 was the normal distribution, so like what the hell's going on? This is a year 11 thing. We're moving on from the normal distribution simply because the next few lessons of that were like shape of the distribution, so like skew and all that, outliers, so like the interquartile range and stuff like that. And that's already stuff you've already done. So I don't want to start repeating things, especially since that was something we did this year. So I thought I'd move to a different topic. The reason I guess I didn't find a topic where there was like, so you can see up here where there's like 10 lessons that are on the same topic is because that doesn't actually exist in standard. The topics are quite short and different. And so this topic in particular only has 4 lessons. I'm only going to do the first one and the last one. So this is going to kind of be a little bit of a jumble, but I just want to give you a bit of a taste of some of the new things that you haven't seen before in standard, rather than getting you to do something you've already done. So that's why we're doing latitude and longitude. And yeah, I guess we'll jump straight into it. So I guess the first thing you might know about latitude and longitude is that that's something you learn about in geography. And it comes from, I guess talking about a little bit of maths here, it comes from our coordinate system. So our general coordinate system, so on the left here is our Cartesian plane or our number plane, and we have an ordered pair. So our ordered pair here might be like 3 and 1. So that just means I go across 3 and up 1, and that's how I determine a point. And it's the same with a grid or a map, and kind of the same thing, you go across first. So if I was looking for Hunter Hills Girls High School at D4, I'd go across D units, and then I'd go up 4 units, and then it would be sitting here. So again, we go across before we go up. So you wouldn't call this coordinate 4D, you call it D4, just like you wouldn't call this coordinate 1,3, you call it 3,1. So it's important that the order is preserved. Now, it's a little bit difficult to think about places on the world when the world is spherical and not flat, as a lot of people seem to believe. But it can be drawn in a way that kind of represents its spherical nature. So kind of like this, and you'll notice that each of these aren't the same height and or width. Actually, the width is the same, it's the height that's different, simply because it's obviously folded at some point. And this is how you kind of determine. So one thing to note about our coordinate system is that we have some reference. In our mathematics, the reference is our origin, so here. And we say how far are we left and right, so what are we on the x-axis, and how far up and down from the origin are we, or the y-axis. The same thing can be said here, except we don't call them the x and y-axis. We call this, which has got a pretty common name, the equator, and we call this our prime meridian. So, and you'll notice that they're degrees as well, which is a little bit strange. I'll get into it a little bit more specifically in a sec, but essentially it's, let's suppose my origin is here, then this angle here is 20 degrees, and this angle here is 40 degrees, and that's 60. So that's kind of how our latitude is made. One way to remember it, I just remember lat, flat. So latitude is the flat ones, and longitude, I don't know how you remember that, it's just the other one. That's the only way I remember it. All right. One thing that the textbook goes over, which isn't really that important, so I won't spend too long on it, is great and small circles. So a great circle is just the biggest circle you can make by cutting a sphere. So if I get a sphere, I cut it down the middle, that's the biggest circle I'm going to be able to make. So you just imagine I literally grab it in half. It's this face, the circle. If I cut it a little bit smaller, so if I cut it here, this circle is obviously going to be smaller than this circle, so it's called a small circle. That's it. The parallels. So you think about your latitude and the things that go across. It's just everything is obviously parallel to the equator, so you can quite clearly see that each of these lines are parallel to each other. So if you're trying to find the latitude of something, or the parallel of latitude, that's just, you know, how far up or down it is from the equator. The angle is what I was saying before, so it's actually, if that's the center, this angle, this is going to look really strange, but this angle here is 15 degrees, that angle's 30 degrees, same thing. One thing to note is, see how here it's obviously going up by 20s or whatever, and here it's going up by 15s, whatever the scale is on the on the map. But one thing to note is, like, obviously this is going up by 15s, right? This is going down by 15s, but they're not negatives. So like in our coordinate system, we'd have this and we'd say, okay, I'll go across one and down one, and this is like -1, -2. It's not like that. We just say it's 15, and instead of saying plus or minus, we say what direction, and the direction is either north or south, and that's how we determine whether we're going up or down. Northern hemisphere, southern hemisphere, you know how you have semicircle for a circle? A sphere is instead of a semi-sphere, it's a hemisphere for some reason, but that's what that means. Okay, I feel like I've already kind of covered that angle of latitude. That's kind of what I was saying, like the rings, it makes this angle. Anyway, the longitude. So instead of calling it a parallel of longitude, it's called a meridian of longitude. It's no different, just because obviously these two lines aren't really parallel, like if you look at it spherically, but if you were to kind of unwrap it, it would be. But anyway, they call it meridians of longitude simply because the middle one is called the prime meridian. So you think of prime as in like the main one, like Optimus Prime, he's the main transformer, same kind of thing. It's got another name instead of prime, it's called Greenwich, pronounced Greenwich, not Greenwich. That's simply because it cuts through Greenwich, the place, like up here or something. It cuts directly through it, so that's why it's called sometimes that. The angle's a little bit different, so you think about when the lines were like this, the angles were this angle. If you're looking at it sideways, I don't know why I did this for sideways. If you're looking at it sideways, pretend this is the center of the circle, and then I'm coming out of the circle. So how am I gonna illustrate this? So pretend I've spun this way. So center of the circle, I'm now at the edge of the circle on the prime meridian. It's how far left and right I'm going. So how I determine left and right is this angle. So this would be going right. So then it's this in here, pretending this is like a flat in the middle of the circle. How else am I going to explain that? Let's go with the big Lego head. Pretend this is perfectly spherical. I then lift this off, and here's my center, and then I am to the edge of the circle. How far left and right is like this way or that way. That's the kind of angle that I'm making. Anyway, put that back on. If you're wondering what's in there, it's USBs and hard drives. Oh, and determining left and right isn't by plussing or minusing, it's how far west and how far east. So if this is the prime meridian, if I've now traveled 35 degrees this way, the longitude is 35 degrees in the eastern direction, so that way. That was an email. Okay, position coordinates. So instead of using like our grid references, like I would say that this is the point 1, 3 or whatever, we say latitude and then longitude. So latitude will be a number, which is going to be a certain amount of degrees, and whether it's up or down from 0. And the same thing for our longitude, it's just how far across the left and right we are. So you imagine that here's our center. If I wanted to know where Canberra is, I look at my angle. So this is the angle here. That's told me that's 35 degrees, but it's really easy because there'll probably be values up here. So it's 35 degrees south. So then that's my x coordinate. And how far, it's kind of hard to see on this, but if this was our prime meridian, so my prime meridian here, I've gone in the eastern direction. So in the eastern direction, 149 degrees, so 149 degrees east. And it's also a little bit confusing because before I was saying you go across and then up, and this kind of says I'm going up and then across, but it's kind of the opposite if you're drawing it out. So like my if my left and right's, wait, is that even right? Latitude. Using latitude, yeah, that makes sense. Yeah, okay, so this angle looks like it's going up, but it's also my horizontal lines, which is my across. That's why it's kind of confusing. So I just confused myself then. Okay, These mnemonics suck. Just lat flat is enough for me, but if you want different ones, then anyway, this is where they use small and great circles, I believe. Okay, let's get into an actual question. So I'm going to do 3 questions. Okay, so we've got this drawing. The prime meridian, I'm going to label that in red, is this. So that's the prime meridian. So you'll notice that all these points are to the right, which is going to be the eastern direction. And to be honest, I like to draw this in quickly. However you remember that. Okay, so then match the following coordinates to the points illustrated. So 50 degrees south. So I'm starting here, and I'm starting, actually, let me draw the 0 degrees. So that is like my origin. Okay, so 50 degrees south. So I start here, and I go 50 degrees south. So that's here now, just based off this. 50 degrees south, and then 55 east. So east is this direction. So now I'm going to go this 55 degrees to there. So that puts me to there. So that's W. I hope that kind of makes sense. It's a little bit, yeah, a little bit strange because it does seem like I'm going up and down, left and right in the opposite order. Okay, 75 degrees north. So I'm starting here. 75 degrees is all the way up here, north. So probably looking at P or Q. And then I go 0 degrees east, so I don't actually move from this line. So that means I'm looking for the coordinate of P. This one, so I don't go up or down, so that means I stay here, but I do go to the right or east 55 degrees. That means I'm looking at U. 30 degrees north, 55 degrees east. So 30 north, 55 east, so that's south. 0, 0, that's my origin, so that's T. And then 75 north, up here, 55 east, over there, that's Q. So it does seem a little bit weird because here the angle is 55 and here the angle doesn't seem like 55. But if you were to flatten this out, these two would be parallel lines. And so then technically these are corresponding angles. So that's why they don't kind of look the same, but actually they are. This video is kind of long. Oops. Anyway, okay, Sydney's coordinates are this, Tokyo's coordinates are this. What are the difference in lat, long, and which cities further west? So what you can do is draw a quick picture, I guess. And draw a quick picture. Just chuck in this. So if you were about to start drawing a face, call that the origin. Let's call that O. And then think about where we are. So Sydney is 34 south. So 34 south would be, I'm going to draw some lines. 34 south we'll call down here. So it's just lower, I guess. And 151 east. So quite far to the east. That's terrible. I want it to be curved, please. There we go. Okay, so let's call that Sydney. And then let's put Tokyo in. So Tokyo is 35 north, so higher. So north is going to be like up here. Oh my word. North maybe, straight line, whatever. 139 east, so you'll notice that's a little bit further, sorry, a little bit, not as far as this, not as far as that, so we'll call it like that maybe. Please just curve, maybe I want to curve this way. Let me select this, please. Okay, fine, I don't want to. We'll call that there Tokyo. All right, so what's this? This is 34 degrees south, that was 35 degrees north. This is 151 east, and this is 139 east. So we haven't done one yet, but if it was west, it'd be over here. I hope that's clear. Okay, so the difference in their latitude. So I guess you can think about, where should we start? We'll start with, so lat is flat, so that's these. So the difference is just like the difference between them. So 34 degrees south, I've got to get to 34 to get to 0, and then here is 35. So what's this difference? It's going to be 35 plus 34. So for A, it's going to be 35 plus 34, which is 69 degrees. B, C. So for B, what's the difference in the longitude? So that's this distance in here. So it's 151. What's the difference between 151 and 139? So I can do 151 minus 139. That's going to give me 12 degrees. Is that right? I hope so. Yep. Okay, and then which is further west? Well, further west, that would suggest which one's further this direction. That's Tokyo, that's Sydney, so Tokyo is further this way, so you'd say Tokyo. And you know that because Sydney is further east, so that means Tokyo is further west. Don't look how far away that is. Alright, last one. So Goulburn, that's in Australia, has anyone been there? Has these coordinates. Armadale is 4 degrees north and 2 degrees east. Where are they? So this is the sort of thing where you could draw a picture, but you don't really need to. If I want to go 4 degrees north, so that means I'm going up. So that means I need to add 4 degrees to this. And then 2 degrees east. So that means I'm going this direction. And this is already east. So I need to add 2 degrees. I hope that kind of makes sense. Is that right? No, that doesn't make sense. This one doesn't make sense. Maybe I need to draw my picture. I've just confused myself. Let's go with this. Boom, boom. Okay. 34 degrees south. That's down here. If I want to go north, I need to go up. So I need to go in this direction. So I'm going in a negative south direction, if that kind of makes sense. So 34 degrees south. If I then go up here, I'll be less south, so I'll actually be 30 degrees south. And then if I want to go 2 degrees east, so 149 is going to be like here maybe. That's 149. If I want to go further this way, I'm going to be like this. So it'd be 151 degrees east. So the new coordinates, which would be Armadale, are 30 degrees south and 151 degrees east. Cool. Almost confused myself. But yeah, that's it. That's a very long video. Whoops.